Hey everyone, this is Valerie Ann with the Truth Exposition Show. I have a lot of people questioning this asteroid, the near Earth object asteroid, named 2012 DA14, and people seem to be really concerned about it, and of course, justifiably. But what I did was I went to the JPL, which is the Jet Propulsion Laboratory at NASA. So I'm going to let this run through so everybody can see it on their own. I think there was a few people that couldn't get to this, they couldn't find it, so I'm going to really do a quick video and just show you guys what's going on. So now I'm going to forward it to February 15th and February 16th because it seems there are some articles questioning that date, okay? Or those 2 dates rather. So here. So now if you see February, you see it looks like it's kind of close on here. It kind of looks like it hits us, but they're saying it's not going to hit us. And I wish I can zoom in here. I don't think I can zoom. No. So if you also go to February 15th, the astronomical unit to Earth is 0.0034. Then if you go over to February 16th, you see the astronomical unit, the AU, is 2.03-4. Now, I've never seen an AU like that. Again, I'm not an expert, so I'm just doing research on myself. So if anybody can provide me feedback with that, I'd appreciate it. And why there's a -4 in there. I'm assuming it's because it's kind of a little too close to comfort. That's why they have the -4 in there. I'm not sure. So what I did was I put in, let me clear it so everybody can see what I'm doing. I put in the 2.0E, and I think it's a 0, not an O, because I did an O and it didn't come out right. So 2.0E -4. And it comes up as converted to miles, 18,591.16149 in miles. Okay? So when I see that, I also look at this diagram here. Okay, and it gives you a diagram here. The 2012 DA14 passes through the ring plane. Here and here's Earth. Okay, so that's a larger diagram, and maybe that's why it kind of looked here that it's kind of on top of us, because this may be a zoomed in version and it shows it. So I'm not sure. But like I said, a lot of people seem to be really concerned about this. Now, I also want to discuss this, that there are three types of Earth orbits, and I'm sure a lot of you know this, but for some of you who don't know, I looked into this. I had found this. So just so you know, there's a high Earth orbit, medium Earth orbit, and a low. And here are the orbits, the low, medium, and high in kilometers. So the high Earth orbit is either greater than or equal to 42,164 kilometers. Okay, and then the mid orbit right here runs from 2,000 until 42,164 kilometers. Now, let's deal with the mid orbit for a moment. So 2,000 kilometers is converted into miles, and the mile conversion is 1,242.74 miles. And the 42,164 kilometers converted to miles is 26,199.49 miles. So because this calculation, again, I hope I'm right with this, but if this calculation is correct, that leaves the conversion miles from that astronomical unit I entered 18,591 miles. So that, I believe, would fall into the mid-orbit range here. Okay, and if I'm reading this correctly as well, we have weather satellites that are out about 36,000 miles. So it looks like those 36,000 miles is within the mid-orbit range with our satellites. And it looks like if this is 18,591 miles, it obviously passes our satellites. And I also read an article that it could actually take out a satellite. But this is what I also wanted to show people. So the impact probability, and this is an impact table, okay? And this is what it's saying here. Impact probability cumulative is 3.3E -04. But what that is just an estimation, I believe, because here it says impact probability right here. Oops. And it says impact probability is the probability that the tabulated impact will occur. The probability computation is complex and depends on a number of assumptions that are difficult to verify. For these reasons, the stated probability can easily be inaccurate by a factor of a few and occasionally by a factor of 10 or more. So I know that they are monitoring this. We all know that, okay? And everybody seems to be very concerned about this, of course, justifiably concerned. But let's see what happens with this, okay? Then I wanted to read this article. It's very short and it's from Earth Sky. And I kind of frequent Earth Sky once in a while to get some information. And the title, it's dated January 25th, 2010. It's a little old, but I just found it pertinent for people's questions. It states, could Earth's gravity capture an asteroid? And I had that question as well. So let's read on here. It says the Earth can capture an asteroid if all the conditions, basically if there are certain conditions met, that would be the speed, size, and angle of the asteroid, if they were just right. So they have to be precisely a certain speed, size, and an angle coming in. Then it goes on to say Earth could capture an asteroid, but only under certain conditions. The asteroid would have to be a certain size, traveling at just the right speed and grazing by Earth at just the right angle. And then it gives an example here. For example, a bus-sized asteroid grazing Earth's atmosphere might be captured by a planet's gravity. Afterward, Moon's gravity might pull it into a stable orbit above Earth to give Earth a second moon. Then it states planetary scientists believe that asteroid capture was common billions of years ago. The planets are thought to have formed by a process of accretion, where small chunks of debris came together to form larger chunks. So there were lot more chunks, what were now called asteroids, moving through the solar system back then. It also goes on to say also dense gas and dust surrounded the forming planets. When an asteroid passed through this material, drag slowed it down, making capture by a planet easier. Mars' two small moons were probably captured in this way, as were various satellites of Jupiter, Saturn, Uranus, and Neptune. Now, asteroid capture is less common, but it is possible if the right asteroid comes along. So the question is, we have to see if this is the right asteroid that comes along in order for our Earth's gravity to capture it. But again, it has to be it has to meet certain conditions. It has to be a certain speed, size, and the angle in which it's coming in. So everybody just stop freaking out for now. Let's see what happens. Once it gets closer, I'm sure more information will be coming out about this. So I just wanted to do a quick video to let everybody know. Just hang in there, let them do their job, and we'll just continue to do our own research as well. That's the best thing I can tell you right now. Okay, this is Valerie Ann with the Truth Exposition, and I'm out.